For some reason, nobody showed up for class today except for Karis, so I'm just going to do the practice problems, and hopefully that'll help you. These are one of the more complicated problems that we do all year, so that's why I wanted to have a special class on it. So these are called distance problems, and there's like 4 varieties of distance problems we're going to do. Now, you can do these problems without doing it the way that I'm doing it, but it won't help you in the future. So please learn how to do it the way I'm doing it instead of just using common sense. So here we go, practice problem A. Candace and Pangloss walked to the site of disaster in 9 hours. The next morning they jogged back home in 3 hours. How far did they jog if they jogged 4 miles per hour faster than they walked? Okay, first thing with distance problem is you want to set up this little, I don't know what you call it, a diagram, I guess. So hold on a second, let me just get rid of some stuff here. So first they walked, so we're going to call this distance walked, and then they jogged home, so we're going to call this distance jogged. Now their distances are the same because they started here, went someplace, and then started here and came back the same distance. So their distances are the same, so what we want to do is we want to set the distance walked equal to the distance jogged. That's the first thing. These are all called equal distance problems, so they're all going to start the same way. Now the thing to keep in mind is the formula. Distance equals rate times time. That'll tell you how far you went somewhere. Like if you traveled 50 miles an hour and you went 2 hours, then you went 100 miles. So you can always figure out your distance by taking the rate you went times the amount of time you traveled, and that's going to tell you your distance. So what we're going to do here is we're going to take our distances and we're going to divide it into, since distance equals rate times time, we're going to say rate walked, time walked, and we're going to do the same thing for jogging. Rate jogging times time jogging. So we set that up. We call this the mother equation. We have 4 unknowns, so we need to have 4 equations in order to solve this problem. So this is equation 1. Now we need to go out and get 4 equations because we have 4 variables. You need as many equations as variables. So Candide and Pangloss walked to the site in 9 hours. So the time of walking, this is a really easy one. That's why you could probably do this without using the formula, but once they get harder you won't be able to do them anymore. So 9 hours. The next morning they jogged in 3 hours, so the time jogging is 3 hours. And let's see, how far did they jog if they jogged 4 miles per hour faster than they walked? Well, the rate jogging is 4 miles per hour faster. So it's going to be rate walking plus 4. It's not 4 times as much, it's 4 faster. So it's going to rate walking plus 4. Now we have our 3 equations. What we're going to do is we're going to substitute it all in. So TW is 9, so we put that in where the TW is. TJ is 3, so we put that where the TJ is. And RJ equals RW plus 4, so that goes in there. So let's just plug everything in. RW, we're going to leave that variable in because we get to leave one variable in. So we're going to leave this one in because RJ is in terms of RW. So we put RW, TW is 9, rate jogging is RW plus 4, time jogging is 3. Now once you have that, you have one variable, one equation, and you simply solve it. So you get 9 RW equals 3 RW plus 12. We're going to subtract 3 RW from both sides, so we're going to get 6 RW equals 12. So our rate walking is going to equal 2. Now you have to answer the question, how far did they jog? So we're going to take this 2, that's RW, and we're going to put it up there. So the rate jogging is equal to 2 plus 4, which is going to equal 6. And you can't just leave it 6 or you miss a point. It's 6 miles per hour. Miles per hour. Make sure you put your units on. And that's how you do problem A. Let's go to problem B. So here we go. On Monday, Voltaire drove to town at 60 miles per hour. On Tuesday, he drove to town at 40 miles per hour. If the total traveling time for both trips was 15 hours, how far was it to town? All right, so a little bit different diagram. Let's just set it up. Put your lines there. On Monday, he drove to town at 60 miles per hour. So here's his home, here's town. He drove to town. So this is Monday. So this is the distance on Monday. We got that down. On Tuesday, he drove to town. So he's starting from home again, and he's driving the same distance. So this is the distance on Tuesday. Set that up, set up your diagram. You could either go, for these kind of problems, you're either going the same way like this, where the distances are the same, or you're driving back, you're driving somewhere and back where the distances are the same. These are equal distances because you're always going to say distance 1 equals distance 2 to start out your problem. So this one, we have distance on Monday is going to equal the distance on Tuesday. So you should get your diagram down, you write distances equal, and then you divide your distances out. So this is going to be rate Monday, time Monday. You take your distances and change them into rate and time. Time Tuesday. So one equation, 4 variables. We need to get 4 equations. So let's get our 4 equations. These are lengthy problems that take some perseverance. Don't quit too soon on these. So on Monday, he drove 60 miles per hour. So the rate of Monday is 60. On Tuesday, so the rate on Tuesday is 40 miles per hour. And then finally, if the traveling time, so the time on Monday plus the time on Tuesday, it says the traveling time for both trips was 15. So we're going to add those together. And so now we have our 4 equations. This one right here, we have to solve either for Monday or Tuesday. So I'm just going to do Monday because it's first. You always have to get it so that just one variable is solved for. In the previous problem that we did, it already came with this one solved for. So you didn't need to solve it for a variable. So now we have our 4 equations. We start with our mother equation and we just start substituting in. Rate on Monday is 40. Time on Monday, we just solved it for TM, so we're going to put in here our 15 minus time Tuesday. Rate on Tuesday is 40. Time Tuesday, that's the variable we're going to leave in. Since we have it here, we're just going to leave it in here. And then we just solve those. 40 times 15 is going to be 600. I'm just going to check that real quick. Yep. Minus 40 time Tuesday equals 40 times Tuesday. We're going to add 40 to both sides. And we get 600 equals 80. I'm echoing. Huh. Well, Karis just told me we're echoing. Okay, never mind. Equals 80 times Tuesday. And I'm going to take 600 and divide by 80. And looks like I'm getting the wrong answer, which isn't good for my video. This is lesson 92. Let me see if I did anything wrong here. 15 minus times Tuesday. Karis, why didn't you stop me? Rates. This should have been a 60 right here. I'm going to have to go backwards. Sorry, everybody. I put 40 in twice. So time Monday right here should have been 60. I should have drawn my little lines here. Time Monday is 60. Times Tuesday is 40. Times Monday is 15 minus t. So let's try this over. 60 times 15 is 900 minus 60t time Tuesday equals 40 times Tuesday. This works out much better. We're going to add 60 times Tuesday to both sides. And we get 900 equals 100 times Tuesday. The time Tuesday equals 9 hours. Okay, go back and answer the question. How far was it to town? Well, we're just going to figure out distance equals rate times time, right? So it doesn't matter which distance we use, so we'll use distance, since we have the t, distance Tuesday equals rate Tuesday times time Tuesday. So distance Tuesday, the rate Tuesday we have right here is 9. The time Tuesday, or actually the rate Tuesday was 40. The time Tuesday is 9. So you multiply those together. The time is going to be 360. So let me just check something. 92. Yeah. Is it asking for time? How far? That's my problem. This isn't distance. Distance Tuesday is 360 miles. So that is how you do these problems. They might take you a few weeks to get them, but you can't just quit on these. You have to keep trying and trying and trying. So that is it for the practice problems, lesson 92. So I hope you watch this video. Okay, Care, we're done. I'm just going to send this video out now. So you can log out.